Hello, welcome to the second lecture, or the second part of the lecture, Truth Tables for Logical Connectives. In the first part, we learned the truth table definition for the negation, conjunction, and the disjunction. In this lecture, we will learn the truth table definition for the conditional and the biconditional, and then do some practice questions. And those are all of our connectives: negation, dot, negation, conjunction, disjunction, conditional, and biconditional. So the truth table definition for the conditional shows that for any combination of truth values for P, Q, P horseshoe Q will have the following truth values. Whenever P is true and Q is true, P horseshoe Q comes out true, the whole thing. Whenever P is true and Q is false, P horseshoe Q comes out false. Whenever P is false and Q is true, P horseshoe Q comes out true. Whenever P is false and Q is false, P horseshoe Q comes out true. So this one is a little odd because a conditional is only false when the antecedent is true and the consequent is false, only on line 2. That's the only time it's false. Here's an example. If you drive south on the 15, you will get to Los Angeles. Remember, P is the antecedent, Q is a consequent. The antecedent is what follows the if, immediately follows the if, and the consequent is that which immediately follows the then. And I'll show you, the counterintuitive implications of the if-then on the next slide. So first, the first oddity is the third and fourth lines. They seem to be false. So let's go back. When P is false and Q is true, it means the whole thing comes out true. When P is false and Q is false, it means the whole thing comes out true. But I think if you consider it in relation to an English statement, you'll see that it's not so odd, although it still retains some oddity, I think. So consider this one. If you drive south on the 15, you will get to LA. Why don't you ask, when have I lied to you? If you're asking me for directions and I tell you, you know what, like here you're in Vegas, if you drive south on the 15, you will get to LA. You tell me when I lied to you. Suppose that you do drive south on the 15 and you do get to LA. That means the antecedent is true and the consequent is true. Well, have I lied to you? No. I told you to drive on the 15 to get to LA, and you did it. Now, what if you drive on the 15 and you don't get to LA? Have I lied to you? I mean, suppose you don't run out of gas, there isn't any mechanical failure in your car, you just keep driving. Well, yeah, I lied to you. Because you started from Vegas, you drove south on the 15, you just kept driving, and you didn't get to LA. Well, then I lied to you because I said if you do drive south on the 15, you will get to LA. Now, of course, if you drive south on the 15, you'll get to LA. That's just the truth of the matter, but it's an example I'm giving you. What if I tell you if you drive south on the 15, you will get to LA. If it's false that you drive south on the 15, say you drive north, and then true that you get to LA. Say you took a really roundabout way. Have I lied to you? No. No, I didn't lie to you. So if you drive north on the 15 and somehow you end up in LA, I don't know the route that would be, but you go through Utah and then, I don't know, somehow connect to a southern road into Arizona and then go west and you're finally in LA. I didn't lie to you. I said if you drive south on the 15, you'll get to LA, but you drove north. You still got to LA, but it's still true that if you did drive south, you would get to LA. Now, how about the last option, that you don't drive south on the 15 and you don't get to LA? Say you drive north on the 15 and you never get to LA. Did I lie to you? No, you didn't take my advice. I told you to drive south. Okay, so those are all the possibilities. We considered true, 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 false, false, true, false, false. Let's look at another example. If you give me $2, I'll buy you a cup of coffee. Tell me when I've lied to you. Suppose you give me $2 and I go out and buy you a cup of coffee. Did I lie to you? No, I didn't. That's our first possibility. True antecedent, true consequent. What about our second possibility? The second line on the truth table, second row. True antecedent, false consequent. You give me $2 and I don't buy you a cup of coffee. Yeah, I've lied to you. Okay, so then true antecedent, false consequent equals false conditional. What if you don't give me $2 and I still buy you a cup of coffee? Did I lie to you? No, I was just generous. You didn't give me the $2, but I decided, hey, you're a friend, I'm going to buy you a cup of coffee anyway. You know, maybe you said, I really want a cup of coffee, but I don't have $2 on me. And then I say, hey, I'll get you a cup. You know, you can get me back next time or something. So I didn't lie to you. I just said, if you give me $2, I'll buy you a cup of coffee. But if you don't give me $2 and I buy you a cup of coffee, it means I'm generous. What about our final possibility? False, false. False antecedent, false consequent. So you don't give me $2 and I don't buy you a cup of coffee. No, I didn't lie to you, because if you would have given me $2, I would have bought you a cup of coffee. So, although at first, let's go back to the truth table. At first, these two lines, the third and fourth, seemed counterintuitive. If you consider it in terms of a couple of examples in English, it doesn't seem so counterintuitive. It's sort of a natural way of speaking, I think, actually. Now, here's a counterintuitive consequence that I really, I can't really get rid of the counterintuitiveness. It's just the nature of the conditional. It's this: for any true statements A and B, the conditional A horseshoe B is true. So here's one. If the moon is round, then Vegas is sunny. Well, the counterintuitiveness of this is that the statement is true, and yet the moon's being round doesn't have much to do with Vegas being sunny. Okay, so any random statement as the antecedent and any other random statement as the consequent yields a true conditional. That's counterintuitive. We can't really get around it. It's just the nature of the conditional. We don't use those sentences in English. If the moon is round, then Vegas is sunny. So I think that's part of how it feels counterintuitive. We just use conditionals for antecedents and consequents that are relevant to each other. Now, how do you define the biconditional? The truth table definition for the biconditional shows that for any combination of truth values for P, Q, P horseshoe Q will have the following truth values. When P is true and Q is true, P horseshoe Q will be true. When P is true and Q is false, P horseshoe Q will be false. When P is false and Q is true, P horseshoe Q will be true. False. When P is false and Q is false, P horseshoe Q will be true. So a biconditional is true only when both P, Q have the same truth value, otherwise it's false. Okay. So an easy way to remember this is this. Whenever P and Q match in truth value, the whole thing comes out true. When they don't match, the whole thing comes out false. Okay, let me repeat that. Whenever each side of the biconditional comes out true or comes out false, when they match in truth value, the whole thing comes out true. When they don't match in truth value, the whole thing comes out false. Oh, I actually forgot to give you the way to remember the conditional. Okay, so here's the way. You just remember that whenever the antecedent is true and the consequent is false, the whole thing comes out false, otherwise it's true. Whenever the antecedent is true and the consequent is false, the whole thing comes out false. Otherwise, the statement is true. Okay. Now, you might take note of the biconditional. P horseshoe Q has the same truth value as a conjunction of two conditionals, P then Q and Q then P. P horseshoe Q has the same truth value as P then Q and Q then P. If you did a truth table on, you can't now because I haven't taught you how to do it, but if you did a truth table on this, you would see that it has a matching truth table for this. It would be first line for the dot true, second line, third line false, fourth line true. Okay, now let's practice. Let P be true and Q be true. What is the truth value of the following statement? So when P is true and Q is true, what is the truth value of the following, of this statement? A, true, or B, false? True. When P is true, in a conjunction, when P is true and Q is true, the whole thing comes out true. And you can see that that's right according to the truth table. That's the way that you would tell, is by looking at the truth table for the logical connective. Let's do another one. Let P be true. What is the truth value of the following statement? P wedge Q. P is true. What's the truth value of this whole statement when P is true? Does it depend on the truth value for Q? Is the whole statement true, or is the whole statement false? The whole statement is true. If you look at the truth table for the disjunction, you'll see that whenever one of them is, and it doesn't matter which one, P or Q, whenever one of them is true, the whole thing comes out true. When the only time it comes out false is when both of them are false. Okay, let P be false. What is the truth value of the following statement? Does it depend on the truth value for Q? Is the whole statement true? Is the whole statement false? It depends on the truth value for Q. If you look at the truth value, the truth table for the disjunction, you'll see that at least one of them needs to be true in order for the statement to be true. So if P is false, we just don't know if P or Q is true, because if Q is true, then the whole thing comes out true, meaning P or Q is true, P wedge Q. When Q is false, then since P is false, the whole thing comes out false, because whenever both disjuncts in a disjunction are false, the whole disjunction is false. Let's do another. Let P be true. What is the truth value of the following statement? P horseshoe Q. So P is true. Does it depend on the truth value for Q? Is the whole statement true, or is the whole statement false? It depends on the truth value for Q. Remember, with the conditional, when P is true and Q is false, when the antecedent is true and the consequent is false, the whole thing comes out false. Otherwise, the whole thing comes out true. So here we have P is true. If Q is false, then the whole thing comes out false. If when P is true and Q is true, the whole thing comes out true. So it just depends. Let's do another. Let P be false. What is the truth value of the following statement? P horseshoe Q. When P is false, what is the truth value of the whole statement? Does it depend on the truth value for Q? Does the whole thing come out true, or does the whole thing come out false? The whole thing comes out true. If you look at the truth table, whenever P is false, the whole statement will come out true. It doesn't matter what Q is. When P is false and Q is true, the whole thing comes out true. When P is false and Q is false, the whole thing comes out true. Okay, let's do another. Let P be false and Q be false. What is the truth value of this statement? The whole thing comes out true. Okay, that's it. We've defined our logical operators. Next, we will learn how to do a truth table for a compound statement.